CNT125, Chapter 10. We're on the section on passwords and then eventually policies here. Alright, so when we talk passwords, we need to talk hashing. Hashing means transform data through an algorithm. Hashing is not the same as encryption. Encryption is a process where you alter the data, but you do it in such a way that that process can actually be reversed. So, you use a secret code where A equals 1 and B equals 2. Well, the words that you had get converted into numbers and look like it's encrypted, but I literally can reverse that process and get the words back. Okay? Hashing is not that. Hashing is you literally, encrypt the data in such a way, and I hate to use the word encrypt, but you basically change the data in some way where it's locked now and you can't redo it. So where this becomes useful is, think about all of the passwords on a server, all the user accounts, Doug Brown, Sally Smith, and George Jones, and etc. All these people in there. You have their login name, D Brown, and their password, password. That file, that list, if you will, those are hashed. The username and password are combined in such a way, mathematically such a way that you get a result that can't get reversed, but that result is now saved. And where that becomes usable is, if we look down here, you now have, again, Doug Brown goes to log in, and you say, okay, what's your username? D Brown. What's your password? Password. It takes what you plugged in and hashes them using the same hashing process. And if Doug Brown and his password was plugged in correctly, it should, when it's hashed, it should match what's stored in the password file, if you will. So the account was created, Doug Brown password, and hashed together, and then Doug Brown tried to log in, Doug Brown password, and hashed. If those two hashed things agree, then it's like, okay, this must be the true Doug Brown with his password and password. Allow him to log into the network or add himself to the network kind of thing as a user. That's where hashing often gets used because you're storing all this user accounts in a hashed file where if somebody gets a hold of it, great, you can't do anything with it. Everything's jumbled in, a scrambled mess, if you will, and it can't be reversed. Okay, so that's a safe way to safe way of storing passwords because it can't be decrypted. So here in the book they show you encryption where I have my message, I encrypt it using a certain key, I have the ciphertext. Well, on the other end, that gets reversed and I can get the plain text. With hashing, it's not done that way. I have my plain text, D Brown and password, those get hashed together and saved as a certain value. And then when Doug Brown tries to log in later, Doug Brown password, they're hashed together. And if those two hashed things match, then they're like, hey, this must be Doug Brown and his password must be right. If they're altered in any way, if they're different in any way, it's like, well, these two hashes don't match. Don't let this dude log in. I don't know who it is. That's where hashing becomes useful. Most commonly used hashing algorithm today is SHA, Secure Hash Algorithm, and usually people pronounce that S-H-A-W, SHA. Versions are SHA 0, 1, 2, and 3. The book kind of lays out like who developed them and when. NSA developed 0, 1, 2, and then 3 was developed privately, and each one of these are getting a little bit stronger and a little bit bigger encryption, if you will. A little bit bigger, I hate to use the word encryption, but hashing algorithm getting a little bit larger to get it more complex. So these oftentimes you see when you're dealing with password files. And this is where I talked about earlier. The entire password file can be hashed and stored. If somebody were to get a hold of it, it doesn't do any good because you can't reverse it. Anti-malware software. Effective malware protection requires getting the right anti-malware program, monitoring the network, continue updating, and then educating the users. Educating the users on what is malware and what to do when you see it. What to do when you see it. Malware leaves evidence, some detectable only via anti-malware software. And some symptoms are things like these. They give you a whole bunch here. And some of you might have even had these things happen to your own systems. I've had a few of these happen to me over the years as well. Sometimes rebooting, sometimes I've had display fluctuations as well. Unusual error messages, yeah. So unexplained file sizes, significant unexplained system performance, unusual error messages, unexpected system memory loss, unexpected rebooting, display fluctuations. These are all symptoms. These are all possibilities of a malware. And with that, we need to be scanning for, and what do we do to get rid of it? What do we do? Antivirus software implementation is depending on what that particular facility needs. You might do it in a I'll pick on like my church. You might do it by host. Each host has their own malware system running and checking for, because you only have 4 or 5 computers you're dealing with. If you're now dealing with something where you have a couple hundred employees working in a building, you might now have it server-based, where the server downloads, instead of 500 computers downloading the malware database and scanning individually, or downloading all those individually, you might have the server download it, you check it, and then push that out to the 500 clients. That way it's downloaded one time instead of 500 times. And then you might even have cloud-based, where it's handled there and pushed out through the users from your cloud storage, if you will. But there should be something in place. Asset disposal. Mining data from discarded equipment from a company can yield some significant insight in the company. Might even have some sensitive data, and might even cause some legal problems with the data that got compromised. So example, let's say you have a hospital and a computer that has people's like health data on, their insurance on, maybe even their paying information on. If that computer is not cleaned before it is disposed of or sold or whatever, and somebody gets that, you now have a leak of people's personal information, health records, etc., etc. You might have a legal problem in your hands of those people's data might have a lawsuit to say, hey, you didn't do your job to make sure my data did not get leaked. So there are many companies that will hire a disposal service to run a wiping program on drives before these things are maybe sold as reconditioned computers, etc., etc. Okay, so there needs to be a plan for how do we get rid of our old assets, our old computers, our old laptops, etc. There's some policies we're going to mention here at the end. Security policy for network identifies your security goals, risks, levels of authority, designated security coordinator, team members, and what's the job of those teams. And that might change by site. And you usually have roles. You don't put in there, Doug Brown does this. You would have my role, because if Doug Brown leaves and gets replaced by Sally Jones would assume that role of this is what they're going to do as far as our security policy. And they kind of mention that here. You don't state specifically the hardware. You state more of a network-wide. We're going to do these things. We're going to update these things. This is our update plan. Every so many years we're doing this, etc. That way you're not tying to specific operating systems, certain hardware that might get replaced, or even certain people that might change jobs, etc. Our policy goals are these sorts of things. Making sure authorized users have appropriate access, preventing unauthorized users access, protect your data, prevent accidental damage, prevent intentional damage, create an environment where network and systems can withstand and recover from a threat, communicate the employee's responsibility, and that could even be your IT staff's responsibility as well, and having employees sign consent to monitoring, letting employees know, look, we are monitoring for various things for the safety of our equipment, our network, etc. And that's why a lot of places will have a policy about, no personal work on no personal researching or things that you run on the company computers. Bring your own device policy. This has become even more popular in the last handful of years because of the pandemic we had, and a lot of people working from home. A lot of people working from home now. So there's varying degrees of bring your own. Applications, cloud, bring your own device, bring your own computer, and there needs to be policies on how these are handled. Who does what's it need to be able to do, and there might even be configurations that are handled here on, okay, you can bring it here, but we need to install this piece of software that's going to manage and make sure that it's getting updated, that it's not full of malware and connecting to our network and into our network resources and passing malware into our file servers and etc. There will need to be policies on what's allowed and what needs to happen to be able to connect it to the network. Acceptable use policy, you need to communicate to your employees what is acceptable, what you're allowed to do, what you're not allowed to do, and with that, potentially even penalties for violations. And again, if you're working in a place like a hospital where you have lots of people's personal data and so forth, it needs to be clear what you're allowed to do and not to do. And employers should never assume employees know what's acceptable. You need to communicate that, and that's where the acceptable use policy comes in. Some restrictions might include, use the company resources to fill your job, be aware that activities on the network can and are monitored, immediately report suspected compromise of data, always sign off or lock out your device when you're done, don't do anything illegal, don't try to circumvent security restrictions, don't market products, don't forward spam email, don't violate the rights of personal organization, don't violate copyright, don't install or distribute pirated materials, don't copy, digitize, don't export software, etc., etc. And again, these might get more specific based on the facility you work. I'm pointing out here as a hack student, and for that matter, a hack employee, this applies to me as well. There is an acceptable use policy in the college catalog. If you go to My Hack and go over to the student success area and look at the college catalog, they actually have a policy on college computer use, security, internet policy, etc. And it's pretty lenient because we are an education facility. There's lots of things we should be able to research to learn, but it also indicates what you are allowed and not allowed to do on the college resources, if you will. Any facility should have something like this. And again, if you start working in like health careers and so forth, this is going to be a lot more restrictive on what you're allowed to do and not to do. Some facilities you might need to sign or have a non-disclosure agreement. I think of one of my brothers works in the semiconductor field. He works on machines that make computer chips. Well, some of that stuff is highly, highly protected proprietary information for, company A and company B. Well, he can't share any of that information that he's learning about what they're printing on there. So he's very limited on what he's allowed to share on when he's working on a piece of equipment. Sometimes he goes, I don't even know what they're printing. But this might be part of a particular network or facility you work at. You can't share certain information. You're dealing with confidential or private information. You cannot share that, and how that is handled. What is considered private? What is considered confidential? What you can share, what you can't share, etc. Password policy. There should be a password policy that the employers know or have to deal with. And we all know this because we have to type in passwords of certain length and so forth. And these are all things that are part of the password policy. Changing default, avoiding personal info, avoid long real words, long and strong, etc. These are all things that we've had to encounter. And that stuff is usually set in the account you create for that person. I'm giving you an example of a server here, a server account. This is where some of these settings are put on that password. How long, excuse me, what the requirements are for that, how often they need to change it, and so forth. I put this in here to remind you, now this is just a few years old, but these are some of the top passwords that people use because they're allowed. This one here, they had to be 6 characters or longer, so people type 1, 2, 3, 4, 5, 6. And this one they said it needed to be 9 characters, so they said 1, 2, 3, 4, 5, 6, 7, 8, 9. People will do these things unless you put in policies to make sure they don't. And you have to be careful. It's a balancing game, because if you make it too long, they're now going to write sticky notes and hide it under the keyboard. That's what people do. Okay, so this needs to be communicated on what's acceptable and what's needed. If you have privileged users, there should be a policy or agreement here on what they're able to do and what they're not able to do, and let them know that their actions are being recorded and logged. So we have that for, backup purposes, etc. We should also have an anti-malware policy for what are we using, when are we scanning, what are we allowed to share, external storage, USB drives, etc. And that should all be part of a policy too. All these kinds of things, equipped with malware, updates, Users should be allowed know what to do, what they can't do with external drives and that sort of thing. And this would all be part of your malware policy. And that's the end of Chapter 10.